Hello friends, in today's video tutorial we will learn about surface modeling. Today I will start from basics. Uh, Basics means I will talk about how to proceed with surface modeling, how to visualize and how to take the necessary steps to get the desired model. This is our first video about surface modeling, so I will start with basics today and tell you about the tools. Most important tools. Not all of the tools are important in surface modeling. So I have surfaces tab here. You can see if you don't have that tab, you can right click here and select surfaces. You can see there are many options like extruded surface, revolved, swept, lofted, boundary, filled, freeform, planar surface, offset, ruled, and all those options. But not all of them are enabled. You can see that only two options are enabled and all other options are grayed out because these options require some kind of geometry to perform on, and these two operations can start from scratch. So I will start from basic. So I will let's create a sketch on top plane. I will select a center rectangle. Smart dimension. I will go to surfaces and exit, extrude surface. I will extrude it by, let's say, 40 mm. You can see there are 4 walls around it. This is what basically surfaces are. Surfaces are a solid geometry with zero thickness. You can see that there is no thickness for any face here. If it gets thickness, then it becomes solid. Like you can see now, it become a solid. I will delete this feature. And there are few things we have to always remember. You can see that the edge here is blue in color. That means this edge is free. This edge is not connected to any other face of the same surface body. You can see that here also it is blue because this edge is not connected to any other face with this surface. But here you can see this edge is black because this is connecting these two faces of this surface body. In surface body, you can see, never get confused that there are 4 surfaces here. These are 4 faces. 1, 2, 3 and 4. These 4 faces are connected, are part of this surface body which has 4 faces. Now I will just select this sketch again and I will select extrude surface. This time I will extrude it in reverse direction. You can see that we still have that blue line. This is because these two surface bodies are appears to be connected, but these are actually not connected to each other or merged into one. I will expand this surface bodies folder here, and you can see there are 2 surfaces here. That's why we can see that there is a blue edge here. This blue edge is very important because in advanced modelings, sometimes you will have some error, or when you import some kind of tessellation geometry, you will see there will be errors like free gap error, zero thickness error, and all those kind of error, like body is not closed, the surface is not closed. So you can easily find those errors by finding the blue edges. Now I knit surface command is used to merge 2 surfaces which are connected by any edge. Now I will just knit it. You can see though that Blue edge now turned black, but these blue edges are still blue because these faces are now merged into one. And you can see that before we had two surfaces here, now we only have one. That is because these two faces are now merged together. Now I will show you the next command, revolve surface. I will delete this surface extrude here. I will now again go to top plane. I will select this sketch and convert entities. I will select a center line. I will draw from the midpoint here to midpoint here. I will select trim entities and I will trim these parts. I will go to surface, revolved surface, and I will revolve it by 180 degree. So that this edge comes directly here. You can still see that this is there are blue edges here because these two surface bodies are different from each other. Now I will use a planar surface. Revolve surface, as you can see, is used to revolve a sketch about an axis. Be sure that you have one construction geometry, or you have to otherwise you have to use another axis. Let me show you. If I don't use this line, I can use some other axis like this, and the resulting geometry will be around this axis, but we want this one. I will later come to these, but first I will show you the planar surface. In the planar surface you have to select more than two edges to create a planar surface, but you have to be sure that all those edges lie in same plane. That means let me show you the front view. So you can see that all those edges are collinear to each other or you can say are coplanar. I selected all these edges and then clicked OK. If those edges were not together, were not coplanar, you cannot use the planar feature. Then you will have to use boundary surface or other feature or filled surface. We will talk about that later. Now I will use the knit surface because you can see that we have three surface bodies here. I can also select surface bodies from here. Now there is a option here, gap control. Gap control is a useful tool because sometimes when you import some bodies or doing some complex surface modeling, there are sometimes some gaps here. Then you can merge those gaps or knit those gaps using gap control. We don't have any gaps, so I will uncheck it. There is a option, merge entities and create solid. I will use create solid. If first I will uncheck it and OK. As you can see, if I had not used merge entities, we will have two separate faces here. But since I used merge entities, those two faces which were totally coplanar with each other are merged into single face. But still, as you can see, there are no fringe edges. It is still a surface body. Let me show you the section. You can see this is still a surface body, not a solid body. Now we will have to convert it to a solid body. There are two ways. Either I will select create solid here, and this will convert it into a solid body, or I can use thicken feature. Thicken feature is used to provide thickness to any surfaces here. For here, let me show you first. Let's say 2 mm. I will not use this option here. This option is used to first I will show you 2 mm. You can define the thickness here. This is just like shell, and it can provide thickness to any surfaces, convert it into a surface into a solid. uh, Let me show you. You can see that it converted the surface into a solid, but with a thickness here. 2 mm. You can see. If I selected that create solid from enclosed volume, then it will have would have calculated the total volume and then created a solid out of that surface body. And you can see now we have a solid body here. This is the most basic operations here. Now I will talk about some advanced feature. I will delete everything here. I will also delete these sketches. I don't need. Let's keep it that way. I will create a new sketch on right plane and then select arc tool, 3-point arc. I will create an arc with random dimensions. Okay. I will exit the sketch. Now I will create a swept surface feature. You will have to select the surface profile first and then surface path. You can see that it created a swept surface. This feature is exactly like swept boss base feature, except that this feature creates a surface body, not a solid body. Now we can thicken it as per our need. I wanted a 2 mm thickness outside. Now we have a band. Okay, so this was surface sweep. Now I will talk about lofted surface. For lofted surface we need to have a new plane. I created a new plane here to have a new profile, and I will create a feature like this. Okay. Now I will select lofted surface. I will select this rectangle and then this. Okay. Guide curves, I will select this as a guide curve and then I will click OK. You can see that it created a lofted surface from this profile to that with using a guide curve. You could have also used this as a centerline parameter, but the results are a little bit different. Okay. So that was actually a guide curve, because for centerline you needed to have created a sketch from this point to this point, the centers for the profile. Now we will come to boundary surface. Boundary surface is something like lofted surface, but you just have to. You can also select 2 other direction curves. It could have been also used between 2 profiles. Okay. Let me create a new part. I will show you it differently. For example, I created a line here, line here, right plane, a line here, okay, and also, and then a 3D sketch and a line between these 2 endpoints. Now I will show you a lofted feature. Could have created a lofted surface here easily, and these could have been the guide curves here. Okay, let's make it a little, little complicated. I will create a 3D point sketch here. Okay. Here also I will convert this into a construction geometry. I will create 3-point arc here. I'm not sure what kind of result I am going to get. I will create a sketch from here to here. Right click, click the connectors, select this, and okay. You can see that you now you have the lofted surface between those. We can also use boundary surface here. In boundary surface, you have to define two U curves and two V curves. Okay. The results are nearly the same. I will go to that part again. We can also use, there are many other options here, like, let me show you. Okay, here start and constraint. In start and, this was the first sketch. Okay, so I can use normal to profile here. That means there will be a tangency to this plane on which this sketch is made. Also, I can use normal to profile for the other sketch. This is not the result I expected, but the surface modeling is a lot more unexpected. Let's keep it. Because we needed a centerline parameter also. Okay. Same goes for boundary surface. You can also select normal to profile here. You can also do that here. Okay. You can see that there is a little bit of smoothness here. You can adjust the value for that. Okay. Next is field surface. Field surface is basically the planar surface. You just have to tell which one you are for in bounding curves. With 4 edges, for example. Let me show you. First, I will for example, I can use planar surface here, but because this is a 3D sketch, it is not going to let us use a planar surface feature. Okay, so what can we do here? I can use a filled surface here because these are 4 curves. Okay, and it created a filled surface here. It is exactly like a planar surface, but it is for a 3D geometry, like when the planes are not, when the curves or edges are not in the same plane, are not coplanar. Freeform creates a number of curves here, and you can add a curve here, and then after that you can select that curve and make little bit changes according to your need. Okay. Offset surface is used to create a surface offset to a particular geometry. You can see this is a very important tool because let me show you. Sometimes you cannot thicken some geometry, then you can easily create a geometry between these two. Okay, and then you can knit these 3 surfaces and then during it you could have selected create solid, and this could have become a solid geometry. So there are many ways around surface modeling. You just have to select the best tools. Okay, now we have already learned about the offset tool. I will use the ruled surface here. Ruled surface basically is like extending some surface. For example, if I selected this edge tangent to surface, this surface will be increased, but according to the tangency to this profile, this surface. Okay, and I can extend it as long as I want. I can knit it, and you can see the zebra strips here. These are not smooth, they're not very smooth. You can also see that there is a greater deviation here. And after that, normal to surface. Normal to surface is exactly opposite to the tangent surface. Let me show you. Let me delete it. Okay. Ruled surface. Tangent surface. Okay. Now we have two. These two surfaces are exactly normal to each other at 90 degrees. This implies that you can see that nearly the angle is 90 degrees, but you cannot calculate the angle because these are not very, cannot see, because these are not straight lines, these are nearly the curves. So no. Freeze bar is also an important tool. After that, there is a surface flatten. Surface flatten is a new command. It comes from it is after, if I'm right, SolidWorks 2013 or 14. I'm not sure. I had only used SolidWorks 2012 earlier, so I never used that command this much. But it is used to create a surface, flatten the surface, and you can use that area for multiple things, like area of a cloth, piece of cloth, but never assume the case of cloth because the name implies solid. You can see solid, it doesn't say cloth or fiber or anything. It doesn't support these features. Or you can use this feature in sheet metal, where you have to calculate the surface area of a complex geometry for blank calculation, etc. Okay, so surface flatten, and delete this. Fillet, we know it. This command is totally the same. Let me create an extrude surface from this. In fillet, you just have to select the edge, just like now solid modeling, and you can create a fillet around the edge. The fillet, delete face. Delete face is used to delete a particular face. For example, I don't want this face here. We'll use delete face, delete, and this will delete. Now I will use a lofted base, and I can create a tangency to face. Okay. And this will be a little different than that fillet feature. Okay, let me show you. For example, I will see. So this is what delete face does. In delete face, you have some other options too, but that depend upon the kind of geometry. For example, delete and patch, it will create a geometry which matches this and this face. Delete and fill, you cannot fill here because this is not a closed geometry. I will show you that later. No, I will do it here. I will create a line here and go to curves, split line will put some lines here and split the faces here. Now I will go to surfaces, delete face. The result can be totally unexpected here. Okay, so you see this is our tangent. The tangency is wrong here because this surface has to select this face, but it doesn't. It selected the inside surface, the imaginary surfaces it created. So the results are not very accurate with this command. So I will never prefer this. But in surface modeling, there will be many times when you will need to use this delete face command. Replace face we will talk about later. Replace face, delete hole. Delete hole is, for example, there is a hole on this geometry. You can delete this section. These are not very useful feature if you ask me. There is an untrimmed face which is nearly the same. Extend surface. Extend surface will extend. It was just like the ruled surface, but it will extend it according to this surface as much as you want. Okay. Oh, we had to talk about other tapered vector. Okay. For example, tapered to vector. Edge selection, this edge for vector. I will select top plane and other direction. I will select 45 degree and you can see, let's say 15 degree. Okay, so basically what it did, that it created a normal axis to this top plane and then extended this surface at 15 degree of that imaginary axis. Okay, so this is how tapered vector works. Perpendicular vector, it will just create perpendicular to the top plane. You have to select right plane here, or you can select front plane according to your need. Okay, we'll just do according to, for example, in right plane, the normal to that axis is that, and it created a surface perpendicular to the normal axis of this front plane. For sweep, you will have to create some kind of geometry. Select a front plane. It's just like tapered vector with zero angle. So these are basically nearly the same options, these three, but it depends upon the type of uses. Okay, we learned about extend surface. Trim surface, you just have to, for example, let me show you top plane here. In trim surface, you have to select a tool and then you can remove some part of a surface, or you can keep or remove some part. For example, if you selected keep selection here, it will only preserve these faces, this surface upper part, and remove the lower part. But if you selected remove selection, this will remove the upper part and keep the lower part. And we have other option also. For example, if I create a line here, let me show you. Let me make it a surface, extrude surface. I will extrude it toward both directions. Then I will select trim surface, mutual. I will select both these surfaces. Now I only want this and the inside part. Okay, and I will click OK. So we have it only preserved the inside part, okay, the faces we select, and it removed the all other parts. Now you can see that this is a single body because trim surface command uses two surface bodies, but the resulting surface is mostly one, depending upon the type. Because I used mutual, so it involved two surfaces and it created one. Now I can use knit and create a solid, or I can just thicken it with create volume, and this will convert it into a solid body. You can see that this is a solid body. Now we have a thickened cut. Thickened cut basically does what? For example, I have a surface here like this. I will extrude it as a surface like this. Okay, I will use thickened cut and let's say outside. Okay, this basically creates a thicken this surface and deduct it from this body. You can see. Okay, and let me extrude it another direction also. So you see, and cut with surface. If a surface is penetrating a solid body completely, like you can see that this surface is totally outside from this body. Okay, so totally, I will use cut with surface and select this face. I will use upward direction because I want to remove this part, and okay, so surface cut feature, cuts with surface feature, remove this part, okay, upper part, using this surface. So meanwhile I can also show you the replace face. In replace face feature, no, let me first because there are many faces, I will use the easiest way. Okay, we can okay, let's extrude surface, direction 2, cut with surface, upside. Okay, now I will hide this. There's a replace face. In replace parameter, I want this face to be replaced, this, and okay. Sorry, I want to replace this face, okay. You can see that it moved that surface to here. It was nearly we obtained the same geometry, but in later applications, solid modeling, we will use these tools differently, and we will learn other applications. All these tools have more than one applications. Cut with surface will be used mostly. Thickened cut will be less used. Thicken will be used a lot. Surface flatten, honestly, I never used this command. Delete face a lot, because there will be time when you want to delete. There will be uneven surfaces. You can delete those faces and then create a new geometry which will be more smooth. If you are in product designing, then these all commands are very useful for you, and you will be using these commands on daily basis. Okay, so let's come to some modeling exercise. Let me show you some 3D model created with surface modeling. Okay, so first I will create a circle. Okay, here, and let's say the diameter is 80 mm. Let's say 100. Okay, I will use a center rectangle here, and for construction I will convert these into 12. I will trim it. Okay, and I will just do it other way, make you understand it. Now extrude this surface. 400 doesn't matter. Let's say 200, 300. Okay. I will again go to front plane. I will create a rectangle here like this, and select these perpendicular to each other. Will make these all sides equal. There are many ways. I will go to curves, split line, select this. Okay. Now I created 4 edges here. So I basically splitted this circle into 4 parts, 4 equal parts. Okay. I will go to top plane. Okay. I will now create a line here. Let's say 50 mm. Surfaces, trim surface. Sorry, standard. I will use this line as a tool, and I want to remove this part. Okay. I will create a new axis about front and right plane. Front symmetry axis. Okay. Now I will go to features, circular pattern. I will select bodies here. Select this body. Equal spacing. Let's say 4 times. Okay. That surface trim, that axis, I need to increase it now. Let's see 1 time. Okay. Rebuild. Okay, this looks good. Intent is a little more. Decrease it to 100. Okay. Now I am going to create a pipe joint here. I will go to Lofted surface here. Select this edge and this edge. I will go to start and tangency to face. Tangency to face. You can also select curvature to face. It depends upon the type of user. This is about continuity, and you can learn about that. I will tell you about that later. Okay. For now, I will only use tangency. Our purpose is fulfilled by tangency to surface. I will again create a lofted surface here. I can just mirror it because we are working symmetrically, so I will just mirror bodies because this is a different body. I will go to linear circular pattern, this axis. I will select again bodies here, these. Okay. Now there are 12 bodies. 1, 2, 3, 4, 5, 6, 7, 8. How come 12? There's something wrong. Let me see. Okay. Still no more. One more. Delete it. I could have just mirrored it. Okay. Now I will go to surfaces, knit. Okay. Merge entities. Gap control. You can see that there are gaps here. Okay. I want to knit all those gaps. Okay. Now I will go to surfaces, build surface. I'll select this edge, this. Okay. Tangent, light wall edges. Okay. I will just mirror it about top plane. Now go to surfaces, net surface. No, there are no gaps. Okay. Thicken. Let's say 2 mm. Or okay. And you can see that we created a pipe band, and this is how these things are done. Okay. I could have used, surface loft here. Oh, sorry, boundary surface also, but surface loft sufficed our needs, so I used only that. You can see that there are many faces here, so I will just you can go to view, display, tangent edges removed. You can see that this is okay. So these are a few applications of surface modeling. There are many more other applications. I will talk about those in our later tutorials. Thanks for watching my tutorial, and please like and share this video and subscribe to my channel. Thank you for watching.